Okay, I think we can actually start the presentation. So thank you everyone for joining today to this blockchain event that Smash is hosting for you. We have some special guests for with us today, and we're really exciting to have this presentation. So just to introduce myself, my name is Sergio Sanchez. I'm the talent director for Smash. I'm gonna be one of your hosts, um, and we would like to start with some instructions, like a protocol that we will ask you to have during the meeting, right? And then we will start with the presentation. Okay, so this session is being recorded, and I'm sharing my screen. So if for some reason if you cannot see my screen, just let me know. And to start, um, we would like to thank Marcus Daley and Will and Phil Windley for cooperating with us and joining the event, and they will be the main stars of the presentation, right? So we will proceed with their introductions in a few seconds. They will be sharing with us all the knowledge they have about blockchain, right? And talking about the meeting protocol, as I told you before, this meeting is being recorded. Please, you keep your making mute and the camera. The camera is okay. You can, if you want to put your camera on, but sometimes better to put it off. And maybe just to turn your mute and camera on when you're gonna ask a question. Actually, we're gonna have a couple of sections for Q&As at the middle of the presentation and at the end of the presentation. So we also have like a QA box in Microsoft Teams. In the top side of the Microsoft Teams window, you will find the Q&A. You can put your question in there, and uh, and we actually appreciate if you ask your questions during the QA section, so we can keep the momentum and the flow of the presentation. Right? Um, you can post your question, or you can unmute yourself, put the camera on, and ask the question um, in the during that section. Okay. So let's continue. This is the agenda. We will go with an introduction, then we will have Marcus and Phil talking about their experience in blockchain and their overall experience in technology. Then Kelly Phillips, the CEO for Smash, will be um, doing the Q&A along with you. So basically, in the QA section, we actually encourage the participants to ask questions. Um, we will go over the Smash Lab project description, and we also have another two special guests today, two mentors that we selected that we will be helping us with the Smash Labs project. And then Marcus and Phil will be also sharing with us what will be like a solution approach for the project that we want to develop in the Smash Lab. So in the Smash Lab section, we will be providing more information about what the project is and what is that we want to solve. And then you will get more information in there in case you are wondering what the Smash Lab project is, right? And then we will talk about, we'll go over and how to sign up for the Smash Lab project, right? So this is which is like very important for us. We would like to everyone that is participating in the event to also, if you want to participate in the actual project that we're gonna develop later on, you will be more than welcome to enroll in project. Okay. So moving forward, we are your host. So this is myself. I already introduced myself, and we have Kelly Phillips, CEO and founder of Smash, and Kelly's gonna be helping us to moderate the session, right? So Kelly, over to you.
Thanks, Sergio. Thanks for all the work to set this up and for Phil and Marcus to jump in with us. I didn't know anything about blockchain. I thought, what a great way to learn and to get two world-class experts to spill their knowledge and then do a little project. We want to build something. I think you learn most by having a great mentor and actually building something. So I don't want to take a lot of time. We're just excited to have everyone here and participate. you want me to do this part, Sergio, or do you want to? I'll hit it
Yeah.
quick. I'm going to get through
All
it
right.
fast. So we find people in Costa Rica, Colombia, maybe other places, but that's where we've started, and bring them into U.S. companies that want to have folks that work more like an employee, people that might stay around for 5 or 10 years and really be part of the team. Marcus is one of our customers, but he's also an expert on blockchain. So I don't want to spend a lot of time on this part. Just we're excited to contribute to the community and geek out and do something fun. That's really why we're here. So we've got lots of different capabilities, lots of people, and lots of different anything technical. But actually, we have some accountants too, so that we're providing for the U.S. But our focus today is on technology and geeking out with all of you.
Okay. So thank you, Kelly. So it's time to meet speakers. So Marcus, Phil, thank you very much for helping us and for being here with us today. So Marcus, your time to shine.
Yeah, so maybe just a quick intro about myself. I've been a CTO for the last 20 years for a variety of startups, and also Fortune 500 companies, doing a lot of different innovations in a lot of different industries. I thought some of you might get a kick out of when I started my technology career, if you will, at least my interests, maybe. When I was a young kid back in the late 70s, I got a TRS-80, started programming with that, and then something called a VIC-20. I'll be honest with you, when you program Solidity on the blockchain, sometimes it feels like I'm working still with a VIC-20. So it brings back a lot of great memories. But for some people, it might be a little bit frustrating. And there's a lot of limitations on smart contracts still with today's blockchains. But started my technology interest started early. I got a modem in the 80s, which launched me into learning how to do networks. I got an interest in the internet right away as soon as I got into college. And from there, really, for the very beginning of my career, I was into Web 1. So I joined a number of startups, and then transitioned into Intel and Microsoft and a number of other companies, both big and small. And actually today here in New York, I'm at JFK, meeting with a number of companies here as well, talking about different technologies, some of that including blockchain technology. So for me, it's always been trying to keep pace with the technology that's out there. And one of the things I've learned just here at the bottom of my profile, as you can see, is that while right now today there may look like there are limitations to what you might be using, one of the things I've learned over the last 30 years of my career is that technology will move faster than you think, and what may seem like it's a little bit slow today is going to be extremely fast tomorrow and meet those needs. So don't think that today, if you're having trouble, that tomorrow those same troubles are going to be there. So anyway, that's a little bit about me. Sorry about the overhead announcement, but nice to meet everybody.
Perfect. So moving forward with Phil.
Hi, everyone. It's good to be here. I'm Phil Windley. My primary interest technically is identity, although lately that's been self-sovereign identity, which for many use cases implies the use of a distributed ledger or blockchain of some kind. So that's my intersection with a blockchain event. Currently writing a book for O'Reilly called Learning Digital Identity. It'll be my second identity book that I've written for O'Reilly. That should be out in 2023, but you can find almost everything that's going to be in it on my blog, because I kind of pre-write stuff and put it out on my blog to make sure that other people can proofread it for me and tell me where I'm being stupid and making mistakes. So that's just at windley.com, and I'd encourage you to just go there and take a look around and see what we've got. But I'm excited to be here, talk about blockchains and digital identity, and I think the use case that these guys have teed up with credentials for universities is a really interesting one. So excited to be here.
Okay. Well, thank you. Thank you very much, Marcus and Phil. So, following up, we have like the first Q&A sections in case the participants have um, questions for you, for Phil and for Marcus. So we're just opening the space in case somebody has a question for Marcus and Phil, something that you would like to know about their experience. If you have any specific question with blockchain, and do you think that they will be able to answer or just to share the experience? So I'm opening this section right now. So in case you have questions, please put those questions in the QA box or raise your hand. Otherwise, we will continue with the presentation. All right. So, anyways, the QA. Oh, we have no. The QA box should be on the top of the Microsoft Teams meeting, Luis. Actually, it says QA has like two bubbles in there. All right. If not, if you don't have it, no worries. You can just write your question in the regular chat box. Okay. All right. Okay. So I'm pretty sure people will have more questions when we talk about the project and the solutions, right? Okay. So the project that we want to develop is a project that we will do under our Smash Labs. So Kelly, if you want to, do you want to share more information about what a Smash Lab is and describe the project to the participants?
Sure. I had a bunch of questions, but I'll put them in the QA box. Is that where you should put my questions?
Yeah.
I want to know why blockchain is important, what you guys think about it. If I'm a developer and I learn blockchain technologies, is that going to make me more valuable, or is it just going to be a necessity? I have a lot of questions. Maybe we could get a little background. And maybe I'm the most ignorant blockchain person here, and everyone else is at a higher level. But I'd love to hear just a little bit of perspective from our speakers on the importance of blockchain, and especially personally to the audience, to the developers. Why should they care?
Phil, why don't you go ahead and go first?
Oh, you're going to put me on the spot. Well, I'm going to start with a bit of a contrarian statement, perhaps, and that is that for a lot of things, you probably don't need a blockchain. So you should be very careful that you really need a blockchain before you start using one, because they're a lot of work to maintain and govern, and they can be expensive to operate. And so make sure you need one. Now, that being said, blockchains have some properties which make them extremely important for some applications. When you do need a blockchain, you really need a blockchain. The most obvious one of those is decentralized discovery. If you have an application that needs people to be able to discover, what I mean by discover is look up. So say I give you an identifier and you need information associated with that identifier. Looking it up on a blockchain is a decentralized way to discover that. If you don't have a blockchain, your other options are things like directories or databases or things that are almost always run by someone else for their purposes. So, that's I think the most important thing to understand about blockchains is the decentralization makes them really hard and expensive to operate, but when you need it bad. So be careful what you use them for, but do use them when necessary.
Let me build on that if that's okay. I think that's great. Back in the 90s, there was a big push for open source software, and I'm sure Phil remembers this. This seems like it was a battlefront. And this kind of was a part of the internet emerging as well at the time. My personal feeling is that what we're seeing right now with blockchain technology is the emergence of what I would call open information. And most people would like to associate blockchain with cryptocurrencies, but cryptocurrencies are just one form of information. They're not the only form of information. They're actually a very limited and small subset. But the interesting thing about blockchain is not only does it allow the attributes that Phil just described, which is to have distributed trustless, which means you don't have to trust whatever it is, the other party, as long as they're obeying the smart contract, you don't have to trust them. They're constrained by the code. They have to go ahead and enter the information that was supplied, and that information, depending upon how the contract is constructed, can't be removed from the blockchain. So you don't have to worry about data loss. You don't have to worry about your information being censored. So you're really facing this time right now, I think, in history where all of us are, where there's a lack of trust, but a need for information, and blockchains fill that gap. And cryptocurrencies are a part of the ability to be able to attach value to that open information. Now, we're not seeing as much of this as I wish we were, and partially because of the regulators, and partially because of the confusion, and partially because it's a new technology. But I think over time, what you're going to start to see is the emergence of lots of different use cases that have nothing to do with cryptocurrency, but sometimes a token might get attached to it to help give it value. But the value that is attached to that information is solely owned by the individual that created it. So the other aspect that you get with blockchain is something called self-sovereignty. By virtue of the fact that you have a wallet, that gives you the right to that piece of information that you place on the blockchain, and of course, unless you transfer it to somebody else. So not only is that information now open, but the information is now owned and secured to you as an individual, unless you choose to transfer that to somebody else. And you could attach value through tokens and other types of means as well. So I feel like we're kind of entering this stage, the early open source software stage, with open source or open information stage now, like we were seeing in the 90s. I feel that way when I attend events. I feel that way when I listen to the developers who are building the solutions. It just resonates so much like it was the 90s, building on top of these open protocols to make things more open for society. So that's my perspective.
Can you share some ideas of the kinds of projects or initiatives that you might see in exciting initiatives in business, or that you've considered yourself for MacU or other entities?
Yeah, it might. I know Phil's been exposed to a lot of different ones. Let me maybe share a couple here. What I'd like to do is I'd like to maybe select a couple that are not cryptocurrency related, because I think it's very easy to pick on a number of DeFi projects, which I think are very important, but I think we should expand the imagination here, right? And part of expanding the imagination is, to give you a really good one, we all use social media in one form or another. And there's very recently now the Lens protocol, which is a protocol that is available on chain for people to be able to create their own social networks and be able to own the information that they may give out in terms of their posts, or who may be able to subscribe to those posts or monetize those posts. The ability to be able to build your own user interfaces on top of that protocol, so that if you don't like the one that you're using, for example, the Facebook user interface, let's assume, you could go ahead and build your own Facebook, because you own the information, as do the rest of the users. The only thing that you might own as an individual above that is the user interface, which people can electively choose. So the Lens protocol, I think, is a very important part of that open information initiative that I was describing. Phil, maybe you have another one while I'm waiting for this announcement to finish.
I was going to.
You're on mute. There you go.
I was going to expand on that a little bit with, you talk about protocol, and I think that's really important to understand, because often we think about applications and, platforms even, and, it's all under one entity's control. And so Uber, for example, can build the Uber platform, and they get to decide how it all works and how it all talks together. I guess the tough part in some ways about doing decentralized systems is that they need to rely on protocol in order to operate, because you have to get a bunch of people cooperating without anybody necessarily owning anything other than just some piece of it for something to work. So you mentioned the social media protocol. One way to think about protocol and to understand it is to think about something we all use all the time and understand well, and that's email, Email is a protocol. There's a couple of them, IMAP, SMTP, and because email is a protocol, I can have my own email server and I can run it and send email to Marcus at Macu. And I don't know whether they use Gmail or some internal system, or it doesn't matter to me. I don't really care, because in between Marcus's system and my system is a protocol. And as long as our two boxes both speak the right protocol, it all works. I can move over to some other system and my email address still works. And that's the beauty of protocol. But protocols are tough. They're harder than just saying, oh, I've got this whole thing. It's my sandbox. I'm going to build it all and figure out how it all works. Instead, you got to get a whole bunch of people to cooperate with you and use your protocol as opposed to somebody else's protocol. And these things have a way of working themselves out. But yeah, we also talked a little bit about decentralized finance, DeFi, and in some ways that was the first application because it's the easiest. And it's and I don't mean to necessarily take anything away from it. It's not necessarily simple, but it might be the simplest application of blockchain. And what I mean by that is, if you think about the web didn't start off with all of the fantastically complicated things we see today. It started off with people just writing HTML pages and linking them together, which is a pretty simple application of HTTP and HTML and the URI specifications. And same thing's happening in blockchain. We're going to see some of the simpler things now. People are trying to build more complicated things and they're going to fail, just like lots of web stuff failed. But that doesn't necessarily mean that the idea is bad, right? We just need to keep hammering at it.
Somebody's asked about voting, about using blockchain. I suppose it's for elections, and if there are any.
Oh boy. Well, voting. So voting kind of dives clear down into all of the complexities of self-sovereign identity, and then adds lots of other complexities on top of it as well. I served for several years on the state of Utah's voting equipment selection committee. So I got an earful of how voting works and the particular problems that voting has. To give you an idea of the complications of voting, imagine that you're an e-commerce company and people buy stuff from you. You can't know who they are. They actually can't get a record of what they bought. Right? These are all requirements that voting systems have. And somehow you don't have any margin to correct mistakes, right? You don't have a profit margin where you can say, oh, yeah, there's a little fraud, but we'll just take that out of the profits. And as long as it's less than, 0.5%, all is good. You don't have any of that. And so voting is extremely complicated. It might be a great application for blockchains at some point. I think we're probably a ways away from being able to do it reliably and in a way that meets most voting standards, at least in the US. I don't know of all voting standards around the world, but it's a tough problem.
Well, let me get back to.
Let me add, if you don't mind, Kelly. I just want to add to that real quick, because there's another form of voting called DAO Governance, which is very commonly done today on blockchains. And you have the real-world implementation that Phil's describing, which is a great potential future application of it. But today, for those that are running protocols, what they'll typically do is they'll have a group of people who will get involved with the protocol. They'll often hold tokens that they can then use to give them voting power. And those tokens, maybe by just virtue of the fact that they have a large number of tokens, makes their vote worth more than somebody who has a fewer number of tokens. But there are also other very complex or more complex voting algorithms like quadratic voting and soul-bound tokens and others that allow them to be able to have more of the flavor of what you would expect in a more traditional voting system. And these are very important techniques that are used today to manage protocols so that the decisions around what happens next with a protocol is voted upon democratically, and people can start to influence the technology that's being developed on the blockchain. So when you read about DAO, Decentralized Autonomous Organization Governance, often associated with that is the form of voting that is token-based voting.
Yeah, that's a great point. And I kind of jumped right into the, elections process, which is really complicated. There are lots of things between that and where we're at now that we could do.
I'm still trying to get a measure of the personal impact. Like if I'm a developer, an architect, how likely is it that I will need to know this technology, or how likely is it that knowing this technology will make me more valuable, and in what time frame?
So I think you probably talked to a number of your students about this, right? Does this come up at all as a conversation point?
Yeah, I mean, I always I teach a distributed systems class at Brigham Young University, and there is a module on blockchain because it's obviously an important technology for understanding or for building decentralized systems. I think blockchain and understanding blockchain implies a lot of other things, right? So you can kind of use it for shorthand that if somebody is really good at blockchain, they probably know a few other things that are also interesting to companies and other organizations for building distributed and decentralized systems. So I think it's maybe a good measure of, oh, this guy really knows blockchain. Good. That probably tells me he understands things about distributed consensus and failure and other important things that a developer ought to know. I frankly think that almost every system that gets built in the future is going to be a distributed or decentralized system of some kind. And so not knowing how to build those kinds of systems is a big limitation on what people can expect to do in their career.
Cool. Well, I think to stay on schedule, I mean, we're just scratching the surface, it feels like. We're just, starting to get into a little bit. But I think we got to keep going, Sergio. Is that what you're telling me? We need to, we're going to get into we call it Smash Labs, but really it's a learning adventure. We feel like the way to learn is by doing something with intelligently, following good practices and patterns, having a good mentor, but doing something real. And if for those of you that care to learn blockchain at the level that you could put it on your CV, we want to open the door and give you that opportunity. We're going to talk about a project. I think we'll have Luis introduce it because it was your idea, Luis, and introduce our mentors, and we just want to do a little bit of a jam on it. We don't want to just kind of talk. We want to get you guys engaged and start jamming on this particular solution because we're geeks and we love to solutionize. So you got the slide, Sergio. I don't know. Do you want to introduce? Luis gave me this idea, and I thought, boy, that seems pretty. I wouldn't say obvious. I think the most elegant things are obvious, but I like the fact that it was easy to understand. And Luis, you tee it up, and then Sergio, you can talk a little bit about the university, but let's do it quickly so we can get into jamming on the solution.
Okay, sure. Yeah, actually, Luis and Haynes they're gonna have a slide to introduce themselves and talk about it. So the project description for Smash Labs is the actual project that we want to work on. Basically, what we want to achieve is to put academic diplomas and certificates in the blockchain, right? Sometimes our certificates, physical ones, get lost, and you have to go to university, do all the paperwork to get it back. So why not having this in the blockchain, right? Just really quick. The idea is to build an application to validate the diploma and certificates. Smash is gonna, partner. Actually, La Universidad Creativa is a partner already. So we're gonna be working with La Universidad Creativa to obtain academic information, the information that we actually need to use. And we're gonna have two mentors. So far, we have two mentors, Luis and Haynes. You're gonna get to know them really soon in the next slides. And they're gonna be helping us with the development of the application, right? This project that we work on It's ideal for front-end, back-end engineers, UX, UI, quality assurance professionals, project managers, actually anybody in here that wants to join and knows and are into blockchain and technology. Right? So of course, all the information that we're gonna use in this project is gonna be with the prior consent of the participants and students and whoever wants to share their academic information, right? Just to give you more information about the project, um, well, we're gonna meet Luis and Haynes, but after that, we're gonna give you information about how to enroll. And right after meeting is over, you're gonna receive an email with the enrollment form. This is something that we're gonna be handling as a, you know, following up on the event, right? But yeah, let's go and let's get to know Haynes and Luis so they can talk about their background and their experience, right? So we have first in here, Haynes, if you want to introduce yourself, please.
Right, sure. Okay, well, thank you, everybody. Very excited on being here and pretty humbled as well, being in the presence, Marcus and Phil that have been already here in this space for such a long time. I have been mingling with blockchain technology for a couple of years now. Started my own company for the blockchain space, or at least contributing to the blockchain space. That's called DQuest. So we are right now on the startup stage, mostly for a specific market of the blockchain that it's called the GameFi space, right? Which has a few very interesting, real world capacity to integrate, for people that like gaming. So we're here kind of building a reputational layer on top of the space by using, some specific tools. You may have heard of them that are called NFTs, though we do something a little bit different. But yeah, so I've also been, working for other companies, both in finance or healthcare, back Chromatic, NetSmart in the United States for a few years, mostly as an engineer or project lead. So here, my specialty is mostly on data analytics, right? Data architecture, how we can, gather data from A and transform it and just have something that Z can consume, right? For either a group of people or C-suite, right? But in any case, really excited being here, and I hope that we can build a really cool project together. Thank you.
Okay, thank you. So we have Luis, the other mentor we have.
Sure. Hello, everybody. I'm also very excited to be around this kind of presentation. Well, let me give you some brief about me. As some of you probably, I started in the world of blockchain, playing with just Bitcoin like 4 or 5 years ago. Then I started exchanging cryptocurrencies, which led me to learn, about other cryptocurrencies around. From there, my interest grew up more and more and led me to play with NFT and decentralized architectures, like it was mentioned, with different layers. And of course, topics like smart contracts starting to pop up. So I'm very happy to be around this new technology in this area. My strengths probably are in the mobile side, also playing with AWS, Amazon AWS serverless services, IoT, Internet of Things. As for the blockchain, I am learning every day more and more, and gladly to help you in a way I can help. There are a lot of topics, a lot of technologies, a lot of things that we can talk about, probably most of them during this presentation. What else? Probably I just want to say thanks to Kelly for supporting the idea of this project, and to our speakers for taking the time and sharing their experiences with us. That's it.
All right. Thank you, Luis, and thank you for bringing the idea and for helping us with this project, and thank you, Nate, as well. Um, so those are the mentors. They're going to be helping us with the project. So just to give you more information on how to enroll is, but we're gonna actually, you're gonna receive a couple of emails to make an announcement. The first one is with enrollment form. The enrollment form is just a simple form, 2 minutes to complete it. Asking for information in case you want to participate in the project. We will be reaching out after that just to have a quick conversation with each of you and to confirm the enrollment and defining the role that you're gonna have within the project. And then also the project time will be validated by the SMASH and by La Universidad Creativa as a certificate, right? So as Kelly said, we want this project, this adventure, to be reflected in your CVs, right? That's something we want to give you. We want to give you the opportunity to learn blockchain and put it in there. So and the second form that you're gonna receive is just a feedback form with the presentation. So we'll be more than of course we'll be really appreciate if you take the time to provide feedback about the session as well, right? So this is how we're gonna enroll to the project. So now let's go ahead and discuss about the solution approach, right? So remember, the project is to put diplomas and certificates in the blockchain. So how can we actually do that? So Marcus, if you want to share with us your approach and how you can actually solve this.
Yeah, of course. And by the way, if there's an announcement, I'll just put myself on mute for 10 seconds real quick and then come off. I apologize for that. So one of the things you're going to notice in the solution that I'm putting forward here is that I strongly prefer public blockchains because they're decentralized, they're censor-proof, they're trustless, and they allow, if you use the right blockchain, for you to be able to have something stored and made available permanently for however long blockchains are going to exist. And today, there are really only two fully decentralized blockchains. There's Bitcoin and there's Ethereum. The rest of the blockchains out there, it may have some small amount of decentralization, but they're orders upon orders of magnitude less than those two. And that's why you'll find that those are the two that I typically would recommend building anything on top of. But there are lots of different ways to build on top of Ethereum. Not very many different ways to build on top of Bitcoin, although some people are trying to do some innovative things there. So let me start then. In my opinion, if you're going to build something, it should be something that can be connected to the DeFi ecosystem. Not necessarily because it needs to be used in DeFi, but because it is available to the DeFi ecosystem, which typically means it's built on either the Ethereum mainnet or on one of the L2s, because that's where predominantly DeFi takes place. There are some smaller protocols and a few other blockchains, but they don't really amount to anything compared to what Ethereum has to offer today. As long as it is available and can be used in DeFi, you're likely to be compatible with just about anything that anybody might build in terms of today's protocols or tomorrow's protocols. So think about DeFi when you're building this and how it might be integrated there. Likewise, when you think about Web3, which is kind of used as a superset of everything, but often also referenced as a way around NFTs. It's used as a way to be able to communicate kind of the visual side of blockchain technology, gamify being one of those. Often Web3 will find its way over there in terms of a term. Again, if you make sure that what you build is compatible with those areas, you're going to be successful, at least have the most potential for being successful. There's a specification called the W3C DID specification. This is a specification that defines what distributed identifiers are for individuals, entities, whatever it may be, and how those should be stored. Now, I want to be clear that while this is a bunch of people who got in a room and came up with a specification, and that's not always necessarily the best outcome, it is a really good place to start. But ultimately, if you have to make the sacrifice, especially for this use case, because you're not actually building a decentralized identifier, so much as adding a piece of data that might get added to a DID, make sure you build it more for functionality, for usability, for it to become something that people will use. Focus on that than focusing on necessarily the specification. But understanding the specification will help make sure that whatever you build is compatible. The next thing is, I would strongly recommend not storing the actual diploma on the blockchain. First of all, it would be too expensive for that to happen from a gas cost perspective. The data would be too large. You'd probably have to save it as a JPEG or something along those lines. Instead, save it offline into Ceramic or Filecoin. In fact, you don't even have to save an image of the diploma. You could create a standard, or if there's one that exists out there for how to store the metadata for a diploma, you could store that as JSON, for example, on Filecoin or Ceramic. And both of those technologies, which are very similar to Arweave and IPFS and other types of data storage that's used by blockchain technologies, they're just a little bit more advanced, are great ways for you to be able to then store that permanently and not have those ever be taken away or revoked or deleted or censored. So metadata is probably the best way to go about doing this, all the key aspects of the diploma. And you can use, give some examples there using Lurk for Filecoin as a way to be able to build some logic around how that gets surfaced up and delivered to people who may be interested. Or my preference, at least for now, was to use streams from Ceramic, mainly because you can launch a new stream for each consumer, which is very beneficial. You could also choose some other mechanisms as well. There are other networks out there that are layered on top of IPFS, which is really the core backbone for a lot of this. Now, the reason why you would put them onto one of these file servers, one of these file storage mechanisms, is because you want to be able to, especially Filecoin and Ceramic, is you want the ability to be able to control who receives it. So that way, not only can you control who receives it, but you can also control who you might remove it from. Front-ending these systems is logic that allows you to be able to mute whatever types of access may have been there before. And allows you to be able to personalize that such that if the person who was once had access to that file had access to it because you granted it, you could also remove that access at any point in the future. So you're in full control of the information that you're offering, which I think is very important for somebody's private information like their diploma. Now, what I try to outline here is the idea that all you need to do to build this, in my humble opinion, for this prototype that we're talking about, is build a DApp. This DApp, and by the way, there's one of my favorite places to build DApps, so that I don't have to do a lot of work, is a place called Fleek. If you go to fleek.co, Fleek.co, that Fleek.co will automatically decentralize all aspects of the application that's being hosted. You know, Kelly, you mentioned what are some of the use cases? Well, some of the use cases are just hosting websites on decentralized technology eliminates many, if not most, of the security issues that we see today with web applications because it's immutable. The only place, in fact, you can actually do an attack once you're now fully decentralized is either via something called DNS hijacking or by hacking the CDN that typically sits behind. But that's it. Those are the only two main attack vectors that you're seeing with decentralized applications. And so using Fleek gives you the ability to be able to basically, with all the tools you're familiar with, build very advanced, very sophisticated, decentralized applications. And then you want to use something to be able to build your smart contract code with. There's a number of different tools out there for that. Take your pick. Some people might like command line interface. Others might like to have a IDE. But whichever one you may prefer, my preference is Remix, REMIX. It's an IDE, and I found that it's been very capable for me with my programming. Build a couple of smart contracts. One of those smart contracts is to be able to grant access to a stream, a Ceramic stream. Another is to revoke access to a Ceramic stream for a wallet address. In both cases, those are for wallet addresses or for smart contract addresses, right? And then the third function is the ability to be able to give back the metadata if they have the right to receive that metadata for that particular diploma. And if you were to encapsulate all of this into what's called an ERC 721, which is an NFT, you've effectively now created an NFT for the diploma, which then is recognized as a standard across several different applications that are out there. Again, in preparation for supporting DeFi, DID specification, as soon as you start using ERC 721s properly, those often can be embedded in those protocols. They often be adopted with the standard methods that are there. And you can do some pretty cool stuff from other functions that can take as an argument your NFT, right? So just, if you're interested in 721s, that would be a good place to start. And then lastly, 3 DApp calls, which are to upload the data into the file storage, return that, there's typically a hash that's associated with that, which is actually a hash to the stream ID, for example. You return that back to the function that grants the access to the wallet. So it becomes then the actual URL that's returned for that wallet address. You're going to want to upload, get the stream ID, plug that in via the method that I mentioned, or the function method I mentioned on the smart contract, to be able to allow that wallet to be able to access it. And then likewise, going to want to be able to, again, mute or destroy that stream if they don't have access to it anymore because it's been revoked. And you have to do that from a DApp, because the DApp will be using typically Infura or some other technology to be able to invoke the function on the data storage to be able to mute the data, or to be able to add the data or grant access to the data, et cetera, et cetera. Very straightforward, but you have to use a DApp to communicate with the storage. You use Infura or whatever else it may be to be able to communicate with the smart contract. Lastly, I wanted to mention that I would typically recommend doing this via Arbitrum or Optimism. These are L2s on top of Ethereum. L2s are another type of technology that enables Ethereum to scale very rapidly, but still gives you all of the security guarantees that Ethereum has. So all of the decentralization still exists. You just get high speed, extremely low gas costs. And pretty soon, actually by the end of the year, there will be something called ZK AVMs that will be coming out, which are zero knowledge proof EVMs that will start to even further compress the data that goes onto the blockchain and enable some pretty amazing things. You can actually read about Polygon's ZK EVM. And I put a few notes in here, which I won't really go into the details on, but I talk about Starks and Snarks and whatever else. These are just some of the methods that are used to be able to further encrypt, compress, and allow things to be able to scale in pretty amazing ways on these L2s. But these are just the basic requirements. Again, on a public blockchain, Ethereum is never going to go away. As soon as you get it uploaded here and put onto one of those file storage mechanisms like Filecoin or Ceramic, it's going to be there for at least our lifetimes, and probably a heck of a lot longer. So you've now created something that's going to be open information, but it's controlled by the individual. And it's something that has durability, can't be censored. You don't have to trust any parties. You don't have to host any infrastructure. You can do this all for free, basically, on your own, which is pretty cool. So that's the general idea of the implementation. Now, look, there are lots of different ways to do this. This is Marcus Daley's approach. Doesn't mean it's necessarily the approach that you have to take. It doesn't even mean it's necessarily the right approach. But if I were to be building this is I would be building it in some way similar to the way you see here. And I see a question, by the way, just came in from Franco, and let me just address that real quick. What I think about Avalanche, you can use Avalanche if you want to. It has low gas fees. One of the issues, one of the issues with Avalanche is it's not fully decentralized. They'll like to talk about decentralization, but the issue is that their form of decentralization is to create side chains where people can launch their own Avalanche sidechain. That is not a form of decentralization. It actually destroys their ability to carry security, because you're basically fracturing the nodes that would otherwise be securing the network to go secure the side chains that they spin off. That's their idea of basically making shards, but that sharding technique does not work. It's a broken method. And what you'll find with a lot of these blockchains that have spun up over the last year and a half, 2 years, most of them are really just trying to make quick money on their token, but not bringing something new to decentralization and to scaling. And I would consider Avalanche to be one of those. I consider Solana to be one of those. I'd be very careful which ones you choose, because they have not been battle tested. Neither do they have a protocol that enables the ability for those to actually be truly decentralized. Anytime you find that they have 1,000 nodes, 500 nodes, that is not a decentralized network. A decentralized network has hundreds of thousands of nodes that are supporting it, millions of nodes that are supporting it. That right there gives you the ability where even if a country outlaws Bitcoin, it will, or Ethereum, or something else for that matter, it will continue to operate around the world, even in the country that bans it, because it's so fully decentralized that it can be hosted in a way that it can never be taken down. Avalanche is not that blockchain. Anyway, hopefully helpful. I'm always happy to answer the questions, but I want to make sure I leave time for Phil.
Thank you very much. Is there another question in there from Gary Marcus? Do you want to address it?
Yeah, it's that trilemma that he's mentioning there, right? Decentralization, scalability, security. It's called the trilemma. You want to be decentralized, you want to have scale, and you want to have security. You either have to pick two of those, right? Or if you try to pick all three, what ends up happening is you end up compromising on all of them in some way, or at least compromising at least on one of them. And what you're seeing with Bitcoin and what you're seeing with Ethereum is typically speed. They try to accomplish all three of those simultaneously, which is partly why what you're going to find with them is that they're relatively slow. And the reason why they're relatively slow is because their block space is small and their transaction speed is also relatively slow compared to some of the others. But they do that so that very inexpensive nodes, or at least in Ethereum's case, very inexpensive nodes can operate on the network. The design goal of Ethereum is to allow you to have a node that can run on your mobile phone. And they're doing this via data availability sampling and some of the other cryptographic technologies that are coming out over the next year. But their goals remain a node on the phone, which is very different than Bitcoin, where it's a proof of work algorithm, and that requires people to continue to buy more hardware. And I can get into the differences, maybe on a different discussion. But this trilemma is what governs the long-term success of any blockchain, and the only two that have successfully navigated this and continue to innovate would be Bitcoin and Ethereum. And I would argue Ethereum is the right model, given that it's the one that's continued to innovate the most rapidly and the most successfully.
Okay, well, thank you, Marcus, for that. So, just for to keep to be on the schedule, we'd like to follow up with the next section, which is Phil. This is your part. So
Great.
Phil, we'll talk about more about variable.
So Marcus and I did not coordinate our presentations, and it will probably show in some respects, but I do think that what I'm going to talk about is complementary to what Marcus just discussed. It's perhaps up a level in terms of its approach. I don't mean that it's better, I just mean that it's wider range, and you'll see that in a minute, because I'm going to talk about building a virtual university. So before I do that, I want to go just briefly over the ideas of verifiable credentials. So Marcus mentioned verifiable credentials, and I want to make sure that we're all clear on the roles and how they work. So a verifiable credential is a W3C standard about how data can be transferred in a trustworthy way. It doesn't necessarily rely on blockchains, although most verifiable credential implementations do use blockchains. In this diagram, you'll see that there are three primary roles. There's a credential issuer, there's a credential holder, which is labeled as identity owner, but I think credential holder is probably a better term for that. And there's a credential verifier. So imagine, for example, that the credential issuer is my employer, Brigham Young University, and they've issued me a verifiable credential about being a BYU employee. And the reason they issued me a verifiable credential is entirely for internal purposes, right? They want me to be able to open up doors and prove that I'm an employee when I go to the bookstore and all of those kinds of things that, universities and other employers like to do. So in this case, I'm the credential holder. They've issued an employee credential to me. But now I go over to Marcus's credit union, Mountain America Credit Union, and I say, I want to take out a loan. and that's the credential verifier. And they say, all right, prove that you have a salary over $70,000 in order to get this loan. I pull out my employee credential that BYU has supplied me, which in this use case happens to also have salary history on it. And I prove to Mountain America Credit Union that I make over $70,000. And Mountain America Credit Union can trust that data, even though that's the big red X there, even though they don't have a direct relationship with my employer, BYU. That's the idea of verifiable credentials. Now, you could ask, how does that work? Why is that possible? I mean, there's lots of questions. I could write 25 pages for you on how that all works. In fact, I have. But we don't have time to go into all of that today. But there's lots of information about how verifiable credentials work. Now, I want to point out a couple of really important ideas here. One I've already mentioned, and that is that the credential verifier does not have to have a direct relationship with the credential issuer. Why is that possible? Because not shown in this diagram is a verifiable data registry, usually a blockchain. And on that blockchain, the credential issuer has written important information like the credential definition, the schema for the credential, and their identifiers. The credential verifier, therefore, can go to that decentralized data repository and get all of that information about the credential that I just gave them without having to have an API, without having to have registered, without having to have any kind of legal agreement. They don't have to have any of that. That's one of the things that makes verifiable credentials special. The second thing I want to point out that might have slipped past you is I said that the credential BYU issued to me had my salary history on it. What I proved to Mountain America Credit Union is that I make over $70,000. Now, when Marcus was talking about snarks and zero knowledge proofs, what he was describing was exactly that capability, right? To minimally disclose information, that to limit it to just exactly the information that's needed. So the only thing Mountain America Credit Union needed to know was that I make over $70,000. And even though my credential had all kinds of employment data in it, including my entire salary history, they could be satisfied and trust that I make over $70,000 because they got a zero knowledge proof that told them just that piece of data. And because of the magic of verifiable credentials, which I'd encourage you to go read about, they can trust that that is true. Okay, so let's go to the next slide. So this is another important piece of information about why they can trust that. So let's say that rather than an employee credential, what we're talking about now is BYU, the credential issuer, issued to the credential holder, we'll call her Alice, a transcript, a digital transcript, starting to sound exactly like what our project is. And they have written to the ledger the schema and credential definition for that transcript. Better yet, there is a schema that many universities have agreed to that's been written to the ledger. And now Alice goes to apply for a job at Mountain America Credit Union, and Mountain America Credit Union says, good, prove to me that you graduated from BYU like you said you did. And so Alice proves, using the credential, using the digital transcript that BYU issued to her as a credential, she can prove to Mountain America Credit Union that she actually graduated. And Mountain America Credit Union can trust that the credential really came from BYU, and they obviously know what information's in it. But there's another kind of trust that we care about, and that is, why does Mountain America Credit Union trust BYU to issue credentials? That's this bottom triangle with the governance authority. It turns out, in the US at least, there are accrediting agencies. I assume there's similar kinds of things in every country around the world. I just don't know what they're called. Right? And so BYU, for example, is accredited by the Northwest Association of Colleges and Universities, which says that it meets certain standards as a university. So if Mountain America Credit Union, turns out we're only about 30 miles apart, so they obviously have heard of BYU. But let's say that it was clear across the country, they'd never heard of BYU. they could go to the accrediting agency and get information about it. More importantly, notice that the governance authority, in this case, this would be the accrediting agency, can issue a verifiable credential to BYU. And BYU can include that credential when they issue the digital transcript. Therefore, when Alice proves to Mountain America Credit Union her transcript, she can also prove that it came from an accredited agency, right? So this is credential bundling, able to put these things together to prove lots of information in one fell swoop, right? All at once. So this is what I mean when we talk about credentials as the underpinning of how all of this works. Now, Marcus stated something very important. He said, don't write the transcript to the blockchain. So I'll generalize that. Never write any personally identifying information to a blockchain, even in hashed form. You may say, wait, if it's hashed, it can't be got. You can't get it. It's all okay. It allows for correlation. There's lots of reasons why you don't ever want to do that. So what did we write to the blockchain? We wrote the credential schema. We wrote the credential definition, which is actually what ties the schema to the issuer. We wrote the issuer's identifier. And there's one other piece of information we could write to the ledger, and that's a revocation registry, which is implemented as a cryptographic accumulator. And so now that means that BYU could revoke Alice's transcript if it decided for some reason she didn't deserve her diploma. But all of those things get written to the ledger. But Alice's transcript didn't get written to the ledger. Alice's transcript instead got given to Alice. That's what we mean when we talk about self-sovereign identity. Alice holds her transcript along with her employee badge and her driver's license and her national ID card and 100 other documents that Alice has. And she can use those together or alone to prove things to anybody who will trust them. So that's what we mean when we talk about self-sovereign identity. So let's go to the next slide. So this is what I mean when I'm talking about a virtual university. So notice that on the left-hand side in the middle, there's this kind of brown box, which I've labeled virtual university. And the two green boxes are University A and University B. So suppose that over here on the right-hand side in the middle, we've got Alice. And it's labeled here student profile, personal API. Think of that as Alice's wallet, right? So just like just like a wallet that you use to hold your Bitcoin and other things, she has a wallet that holds her verifiable credentials. And what Virtual University has done is they've said, okay, we will accept these courses from University A and these courses from University B. And we don't actually teach any courses, but if you've taken those courses from these other universities, we will issue you a diploma based on the fact that you've taken a set of classes that constitute a degree. Now, we could have lots of interesting discussions about whether an accrediting agency would actually accept that or not, but just take it as a fun challenge to think about how we could do this. So now what happens is when University A and University B and maybe C, D, E, and 100 other universities, all using a common credential schema, Alice, Bob, Charlie, all of the players in our little over here on the right take these courses from all these universities. They get credentials from all of them saying Alice took this course, Bob took this course, etc. They can then prove to Virtual University they took all of the requirements for a degree in computer science, say, or a degree in accounting, and Virtual University will now issue them a credential, giving them a diploma for having completed all of the requirements for accounting or computer science. So this is what I mean by Virtual University. Everybody is transferring data as verifiable credentials that everybody else can trust and understand because it's all based on a common standard. All of the players on the left are organizations, so they all have things written on the blockchain. All of the players on the right are people, so they don't have things written on the blockchain. Rather, what they have are credentials that they're holding in their digital wallets. So there is information, that link on this slide will give you kind of a rundown of what I mean when I'm talking about virtual universities. And there's some other links I think that, that Sergio has in the deck for other things. My blog, Windley.com, also has other things on verifiable credentials and decentralized identifiers. Verifiable credentials are all based on decentralized identifiers, something Mark has talked about. So I actually didn't realize I was supposed to write up the project plan. So I'm just going to tell it to you, and maybe Sergio or somebody can get it from me later and distribute it. Okay, so here's my project plan. I'm going to post something in the chat.
Phil, you're mute. And actually, we have two questions in there.
My apologies. Somehow hitting return caused me to mute because my cursor wasn't in the box. I don't know. Anyway, so a couple of questions there. One, are you familiar with Kilt protocol? I have not heard about it, so I'm not familiar with it. My thoughts on the future of decentralized identifiers. Well, just in the last 2 weeks, I think, the decentralized identifier specification was approved by the W3C, which is very exciting news. I think decentralized identifiers are really important because what decentralized identifiers allow us to do is to keep our own public-private keys and rotate them, which is something that digital certificates have not allowed us to do. It's really hard to rotate your keys with a digital certificate, which has made the personal use of public-private key pairs really hard. I think decentralized identifiers fix that. Now, most people probably aren't going to be aware they have decentralized identifiers. They're just going to know that they have a relationship with someone. Now, the relationship is based on the fact that you and the other person exchanged public keys via a decentralized identifier. You probably won't know that, right? But that's okay. Underneath it all, right, most people don't understand that HTTP is what makes the web work. That's okay. They don't have to know that. Underneath it all, this is all going to work. And I think decentralized identifiers are one of the foundational pillars, along with verifiable credentials, of self-sovereign identity. And I think that's a really important technology. So let me tell you the project plan that I have. So I just posted a link to a thing called Trinsic ID. Trinsic is a company that will let you create credential definitions, schemas, and other things for issuers. It also will let you issue credentials to a wallet. And so now you can imagine you could create University A, you could create University B, you could create University C, and you could create the virtual university. You could then have some users, Alice, Bob, Charlie. They don't need to have anything defined inside Trinsic, but they're going to have a Trinsic wallet. Now, Trinsic wallet is all based on standards. Again, we could talk about interoperability and lots of other ideas, but there's not enough time. So just for now, just say, oh, I'm using Trinsic, but understand that it's all based on standards. So there's interoperability that happens underneath the covers. So Alice, Bob, Charlie, those guys are all going to have Trinsic wallets. So now build that, right, using Trinsic. Figure out what the credential schema needs to be. Maybe you're going to have multiple credentials. Maybe you'll have one for transcripts. Maybe you'll have one for courses. Figure out the schemas. Create credential definitions for each of the credential issuers, A, B, C, etc., that you have. Then let Alice, Bob, Charlie, and other people who have wallets issue credentials to them saying they took different courses, and then prove using the wallets and the credentials to virtual university things about all of these players. So this is essentially what you're implementing, right? So this is what I meant when I said it's maybe a level up from what Marcus was talking about. Marcus is, talking about all of the technology down here. I'm saying use Trinsic as your kind of API for doing all of that, and then build on top of that a working proof of concept of a virtual university. So you could do either of those or both of those or combine them or whatever you'd like to do. So.
Yeah, and actually, I'll just comment on that real quick. I do think that what you just said there at the end, Phil, is really important. Some people are going to be very turned on by getting down into the weeds and understanding exactly how the tech works and the code works. That's not necessarily the right way to do it, right? For a lot of other people, using a SDK or even a higher level tool is a better way to go. At the end of the day, though, a lot of it depends on what you want to do with your career. Do you want to be a low-level developer, or do you want to be somebody who's more focused on, as a part of your brand, somebody who delivers solutions, right? And the faster you can deliver solutions, which is kind of what Phil was suggesting there, the better that would be for your career, if that's what your career is about. If your career is about knowing the ins and outs of the way blockchain works, the technology, and how to be able to optimize, then taking a more detailed level view would be the right one. But both of those work great, I think, for this particular project. Just pick the one that's best fit for what you're looking for with your career.
That's a good way to put it.
And we might divide into teams that have those focuses. So the people that want to assemble from the little parts and the people that want to be more of a solutions architect and integrator.
Okay. Well, thank you, Phil and Marcus. Kelly, actually, we're approaching the end of the presentation, so I just want to check if people have questions for. It could be for us, for Smash, about the project, for Phil, for Marcus. So this is time to. We still have some time, but if you have questions, this is the time to throw those out. Well, seems everything is clear then. Okay, well, that is the case. Well, we have a question from Gary. It says, can you talk more about rollups?
Yeah, happy to talk about that for a moment. So when I was talking earlier about L2s, L2s are effectively rollups. And what happens is, and the way that they work, is that they process the transaction and they then compress that transaction, typically using a ZK snark is the most popular way to be able to do that today. And then they will use what's called a sequencer, but they will take those, the bytecodes of the snark, and they will sequence them in and record them into a Ethereum transaction. So in an Ethereum transaction, you could compress down hundreds, if not thousands, of transactions into a single Ethereum transaction. That's why it's called a roll-up, because you basically roll them up, put them into that transaction, commit the transaction. And they typically use, well, ideally they'd be using snarks for that, because the size of those of the byte code for a snark is very small. It's just bytes. But today there are no production-ready, fully capable, Turing complete ZK rollups. So what you see today with rollups are usually using what are called fraud proofs. And fraud proofs are an expensive way of doing this, but they still roll up the transactions, compress them, roll them up, and then commit them. And that's what Optimism and Arbitrum are. They are called fraud proofs. But very soon, those will all transition over to ZK Starks or ZK Snarks. So anyway, the notion of a rollup is just basically compressing a bunch of transactions into a single Ethereum transaction. That's how you get scale. Trying to break that trilemma that was asked a little bit earlier in today's conversation. Breaking the scalability trilemma.
Okay.
Rust, if you don't mind, I'll comment on that one as well. Rust is an interesting language. You do find Rust, for example, in Solana. My humble opinion is that I would steer clear of Rust. Phil probably can relate to this. I know maybe one or two other people on the call can. Back in the 90s, there was a battle going on a variety of fronts, on a variety of standards. And one of my favorite ones was JavaScript. There were lots of different scripting languages that were supported in the browsers at the time. And I'll be honest with you, I hated JavaScript. I actually still don't like JavaScript. The JavaScript was just messy, you know, it just was not strongly typed. You had all kinds of just weird stuff. And now it's been made a lot easier because the libraries out there are fantastic, right? It's really been turned into something pretty amazing. But what I would argue was not the best solution at the time. There were other languages that were better, but it didn't win out. Those other languages didn't win out. And what we're seeing today with programming languages in blockchain is Solidity is without question the clear winner. Anytime you can write Solidity, you now have the ability to go into a multitude of EVM chains. All zero knowledge proof implementations are being done using Solidity as the language. They are not doing something else. So at this particular juncture, I would consider Solidity to be the JavaScript of the blockchain era. Yeah, so I would just start first with Solidity and stick with Solidity. I think you'll be good.
Okay.
Does that answer that next question? What languages and tools? Phil,
Yeah, I think it does. Yeah, just stick with Solidity. I think if you try to deviate from that, you're going to find that you're going to go into a niche that's probably going to die out as a branch at some point in the future. And that learn web3DAO.io is a good one. There's another one that I like as a site. Let me after I hang up here. Let me before I jump on my flight see if I can find a link. I'll post it in here. I think everybody will still have access and can see what I post. There's one I've typically recommended. I don't have it right in front of me, but I'll see if I can find it. It has videos and the text, and I found that was really useful to learn Solidity as well. I'll get that out to everybody. But there's a lot out there, man. There's lots of information, especially about Solidity, in terms of YouTube videos, websites, tutorials, really well done. There's just a rich set of information out there now, and if that's what you're choosing to learn as your programming language. I don't know, Phil, would you recommend anything different? I know you've got a lot of extensive experience.
Right. I keep muting myself. No, I wouldn't necessarily recommend anything different. I mean, Solidity. If you're doing smart contracts on Ethereum, knowing Solidity is the way to go. And clearly, you know, as more and more people want smart contracts, that's going to be a language that is in demand. You know, if you're looking to like work on blockchain projects, they're going to be all over the map, right? They're going to be C, Go, Rust, you name it, they're going to implement in different languages. So that's hard to predict. But yeah, Solidity is a good choice.
And if you don't mind, let me just clarify that for everybody, because that's a really important comment. The view that I have of the world right now is I would not recommend building your own blockchain. I would go with the public blockchains that are out there. Don't build your own. I don't think you're going to get, I mean, you could argue Cosmos brings something to the table. Maybe a few of the others bring some things to the table. Somebody mentioned Polkadot, you know, which is interesting blockchain, in my opinion. But at the end of the day, though, I think that you're really reinventing the wheel unless you've got some truly, absolutely on the fringes use case where that's absolutely necessary. And if you do, then exactly what Phil said, there's a lot of languages that end up getting used, and it's very complex. Stick, if you can, with smart contracts. Use a public blockchain, use an L2 where the gas fees are very low, and I think you'll find you're very happy, very productive, able to accomplish all of your needs, and you can stick with one programming language, maybe one or two others like, you know, JavaScript for the dApp side of things, and a few others. But just don't. I would steer clear of having to build your own blockchain unless you're planning on taking on the world, because it's a bear, that's for sure.
Yeah, somebody asked about Corda and Hyperledger, and Mark has been talking a lot about you know, public blockchains like Bitcoin and Ethereum. Having been chair of the Sovereign Foundation, which was responsible for 3 Hyperledger projects, Indy, Aries, and Ursa, I have to put in a little bit of a plug for Hyperledger. There's a lot of good work going on there. There's a lot of companies using that technology. There are a lot of places you're going to show up to work where they're still a little leery of putting lots of stuff on a public blockchain. And so, you know, sometimes those kinds of networks, I mean, I don't like to call them private because most of them are open. but they are governed, right? And so I think there's a lot of interesting stuff happening there. And you know, Ursa in particular is a cryptography library, which I think is really interesting to look at. It's got a lot of basic functions that lots of people have looked at. Right, you never want to write your own cryptography, so use something somebody else has written and lots of other people are using, and Ursa fits that bill.
Yeah, maybe just to add to that, I know there's a little bit of background noise, but I have a patent on blockchain technology. There's two technologies I use for this patent. This is a very important patent at the time. We actually used Hyperledger and we used IPFS. So just by virtue of using those two technologies does not preclude you from being able to do patents. You can do some pretty amazing things using off-the-shelf open technology like Hyperledger and IPFS, for example. So just wanted to highlight that you don't have to invent something from scratch to not have unique intellectual property, including using off-the-shelf tools like Hyperledger and IPFS.
So someone asked about how to get started. What would a beginner do? I'd welcome them to be part of the lab. We're going to have a variety of people, the variety of skill levels, and we have to do some simple things with a web app. We have to help integrate the university. So it's not going to all be at the depth that we're listening to these two experts speak at. And we have our mentors that will help with that. But maybe you guys have an answer to where would you go if you wanted to really get your first introduction? How would you get started that way?
Let's go ahead, Phil.
All of my interest and expertise on this is in the identity space, and so, you know, I put in the chat. There's a great book called Self-Sovereign Identity by Prescott and Reed. Of course, you know, it will be eclipsed by my book when it finally comes out. But, you know, until then, you know, that's a great book in the self-sovereign identity space. They talk about verifiable credentials. They talk about decentralized identifiers, ledgers, digital wallets, key management, all of that important stuff. So not necessarily directly ledger related, but in the self-sovereign identity space, I'd recommend that book.
Well, when your book comes out, we want to buy a bunch of them and have another section like this, Phil. We love to drill in on identity. I know it's going to be next year, but
yeah,
so put us on the buyer list.
Okay, that'd be great.
Well, you can read his blog. Phil's blog is always full of lots of stuff leading towards his book, so it's always great to read.
I think it was a time, I'm not exaggerating, that Phil was the #1 blogger on the entire internet.
I don't think I was ever that.
No.
Maybe
it was
in
a long time ago.
The most interesting, anyway.
Yeah.
That's great. You know, if you really want to go basic, right? So just to even get familiar with the space, there's a podcast called Bankless. I would recommend that everybody listen to Bankless.
Bankless. Okay, we'll put that on the list.
Broadcast.
Well,
yeah,
we're
sorry about that, Mike. I'm sorry, I just want to finish. I got cut off there. Make sure you look up Bankless as a podcast. That's the one I want to recommend. Yes, thank you.
Okay. Cool. Well, we're at the end of our session. We really appreciate you guys. I learned a lot. It was, there's the link. They're asking about Bankless. And this was a great start. If you're interested, we hope to see you join a lab and we can keep learning. Maybe we could ask you guys to evaluate our final solutions and just keep in touch with you and let you know how things progress.
Yeah, I'd like to know how people do.
Yeah, agreed. Definitely.
Awesome. Thanks, everyone. Thanks again, Sergio, for making all this happen.
Welcome. Thank you, Phil. Thank you, Marcus, for joining. Haynes, Luis, thank you very much. Thank you, everyone, and have a great night. And I will be sending you emails with the enrollment form and also asking for feedback. That's always helpful. So thank you.
Awesome.
Thank you guys. Thanks everybody.
Yeah, thanks everybody.
Thank you. Bye.